There are over 130 million pieces of space junk orbiting Earth right now. Dead satellites, rocket stages, fragments from collisions. We call it debris, a hazard, a ticking time bomb. But what if it's something else? What if this junk is one of the most valuable resources in human history? Because by 2026, the race has already begun. Not just to clean it up, but to mine it. For decades, we've been building a graveyard in orbit. Since the first satellite launch in 1957, thousands of machines have been sent into space. Many still work. Most don't. They drift. They collide. They break apart, creating clouds of debris, moving faster than a bullet. At those speeds, even something the size of a screw can destroy a satellite. This is the Kessler effect. A chain reaction. One collision creates more debris. More debris creates more collisions, until space itself becomes unusable. But hidden inside that danger is opportunity, because every piece of debris is not waste. It's material, refined, engineered, already paid for. Think about it. Launching 1 kilogram into orbit costs thousands of dollars, sometimes tens of thousands. Now imagine a dead satellite, weighing 5,000 kilograms. That's millions, sometimes hundreds of millions, already invested. And what is it made of? High-grade aluminum, titanium, carbon fiber, copper, rare earth elements, even gold. On Earth, you would mine, refine, and process these materials. In space, they're already finished, waiting. So the question changes. Not how do we remove space junk, but how do we use it? First, you have to catch it. And that's harder than it sounds. Because in space, nothing is standing still. Everything is moving at extreme speeds, spinning, drifting, unpredictable. So engineers have designed new ways to capture it. Robotic arms that reach out and grab onto drifting satellites. Nets that wrap around debris, like a trap. Harpoons that latch on from a distance. Magnetic systems, soft gripping mechanisms, even experimental adhesive technologies. Each designed for a single purpose: to take control of something that was never meant to be touched again. But capture is only the beginning. The real value comes after, because instead of bringing debris back to Earth, we process it in space. Imagine a floating factory, machines cutting apart old satellites, separating panels, extracting components, melting metal, using solar energy, then printing new parts, using that same material. A broken satellite becomes a new structure. A discarded panel becomes a tool. A dead system becomes fuel for something still alive. This is not science fiction. It's already happening. Some satellites still carry unused fuel. Others have working parts. Solar panels, thrusters, electronics, all of it valuable, all of it reusable. And in space, reuse is everything. Because every kilogram you don't launch from Earth saves enormous cost. This is where the economics shift. Space agencies are already paying to remove debris. Companies that can do it cheaper make profit. But that's just the beginning. Because the real money is in what you recover. Materials in orbit are worth far more than materials on Earth. Not because they are rare, but because they're already there. A single satellite could generate millions in reusable value. Multiply that by thousands of objects, and suddenly, space junk is no longer a problem. It's an industry. But there's one major complication: ownership. In space, nothing is truly abandoned. Every satellite belongs to the country that launched it, even if it's dead, even if it's broken, even if it's been drifting for decades. So if you capture it, who owns it? You or them? There is no clear answer. Some propose licensing systems. Others suggest abandonment laws. Some want a global framework for space resource rights. But right now, it's unclear, which means one thing. We are at the very beginning. And like every new frontier, the rules haven't been written yet. That creates risk. If something goes wrong during capture or processing, you could create more debris, worsening the very problem you're trying to solve. There's also a deeper concern. Technology that can capture debris can also capture active satellites or disable them, which means debris mining could become a weapon. And then there's the question of control. If one company or one country dominates this industry, they don't just control debris, they control the supply chain of space itself. Despite the risks, the momentum is unstoppable. Companies are already testing systems, robotic capture missions, fuel transfer technologies, on-orbit servicing. Step by step, we are learning how to operate in space without relying entirely on Earth. And that changes everything, because the future of space is not just exploration, it's infrastructure, recycling stations, manufacturing hubs, fuel depots, all built from what we once called trash. By the early 2030s, this could become normal. Debris is captured, processed, reused, launch costs drop, new missions become cheaper, the risk of collisions decreases, and the space economy becomes sustainable. The first company to truly master this won't just clean up orbit, they will control the raw materials of space, and that kind of control creates enormous power. So here's the shift in perspective. Space is not filled with junk, it's filled with opportunity. Every broken satellite is a future resource. Every fragment, a piece of potential. The same debris that threatens our systems may be the key to building new ones. One person's hazard is another person's industry, and in space, it might be worth billions. So the next time you look up at the night sky, remember, you're not just seeing stars. You're looking at a hidden economy, a floating inventory of metals, machines, and materials, waiting not to be cleaned up, but to be used. Because the future of space won't be built only by launching new things. It will be built by reclaiming what we've already left behind. And the first trillionaire of space might not be an explorer, but a recycler. If this changed how you see space, stay curious, because the biggest opportunities in the future won't look like opportunity at first. They'll look like problems.